All right, Jim, you ready to get started?
Yes, if you're ready.
Yeah. Well, good afternoon, everybody. Thank you for joining us today. We know fertilizer has been a challenge for folks across the country, and so we've asked our Director of Agronomy, Jim Spindler, to do a presentation on how you can use practices and products to increase fertilizer efficiency. And Jim is a certified professional agronomist, a certified soil scientist, and a certified crop advisor. So he's got a lot of experience working with fertilizer products and best practices. And without further ado, Jim, if you want to take it away, and I will just ask that if anybody has any questions, please add those into the chat, and we will address all the questions at the end.
Okay, well, thank you, Sarah, and welcome everyone. Good afternoon. Hopefully everything's well with you where you are. This webinar on increasing fertilizer efficiency is part of our series of events for National Lawn Care Month, which is April. So this is helping to support our lawn care industry. And speaking of lawns and turf grass, how much of it is here in the United States? And in 2005, it was estimated that 1.9%, or almost 40 million acres of turf grass, is in the United States. And when you add Canada and other countries to our south, it really increases dramatically. And it's commonly understood that most native and construction disturbed urban soils where turf grass is normally doesn't have enough nutrients to properly support turf grass and lawns the way it's desired or to be healthy. But with that comes fertilization, but on top of that, fertilization can be mismanaged and can be a problem to the environment and all that. So we're going to go over today fertilizer efficiency topics and how to maximize your fertilizer efficiency and why. So then the first topic in this talk is, why is fertilizer efficiency important to us? And there's 4 areas I want to identify. One is environmental considerations, and then cost, which is with today's environment in our economy is very important. There's regulatory considerations to maximize fertilizer efficiency, and then there's some quality aspects that step into it. So as I said, environment is the first one that most people think of when they want to improve fertilizer efficiencies. And that includes things like protecting groundwater. And when we talk about groundwater, most of the time we first think about nitrates, nitrate leaching. And the EPA has some groundwater nitrate limits, like 10 parts per million is what is considered the maximum allowed for drinking water. But there's also things like pollutants that you're worried about and other chemicals that are applied to the ground. And it turns out turf grass is a particularly efficient way of grabbing these kinds of pollutants that end up in groundwater, so that a well-maintained turf, while it's still using just the right amount of fertilizer, is important to protecting our groundwater. And then when we're talking about the environment, we're also talking about surface water. So again, nitrates is an issue, but we see in many states a concern moves into phosphates and what they do as far as contributing to algae blooms and things like that in waterways. Then we have other nutrients, and again, pollutants, chemicals and pesticides. And of course, turf grass is very important in protecting surface waters from erosion. So all this is important when we talk about fertilizer efficiency. When we talk about fertilizer costs, again, like I said, in today's economy with our inflation, we've seen dramatic increases in fertilizer costs. And we look at raw ingredient costs since September of 2020, we'll see that things like anhydrous ammonia, which is an ingredient in most of your nitrogen fertilizers, is up 200% in a year and a half, roughly. Liquid nitrogens are up 162%, urea, another building block for a lot of your fertilizers, up 141%. Things like some of your phosphate sources up 74%. Potash has taken a big jump lately as a potassium source, and that's up 125%. And then anyone who heats their house during the winter knows natural gas is up dramatically. And that's a key component in constructing nitrogen fertilizer products. And that's up 180%. Now, when we look at finished fertilizer products, we're hearing prices up, at least up to 300% increases. And I saw this example in the literature where if you bought a bag of fertilizer in the spring of 2021, it was about $12 a bag. And by last fall, it was up to almost $15 a bag. And this spring, they're saying that same bag of fertilizer is $20. So the economics of fertilizer efficiency becomes very important nowadays when you're treating not only a home lawn, but if you're treating hundreds of acres of turf and landscape. A couple dollars a bag adds up very quickly. So we want to get the most out of that fertilizer bag. Now, on the regulatory side, fertilizer efficiency is being regulated quite regularly in many states. We look at states like Minnesota, Michigan, Pennsylvania, Wisconsin are all limiting phosphorus applications, with the exception of maybe establishing new plants or new turf. Phosphorus is banned in most turf maintenance in several of these states. Here in Florida, where I am, many coastal communities and now others coming inland are starting to have nitrogen blackouts so that the nitrogen doesn't enter the waters around Tampa Bay and other ocean communities and causing red tide. That's what they're considering the cause. Many states do have suggested and are moving towards best management practices. Here in Florida, our local Turfgrass Association is really strongly promoting best management practices so that regulations don't come in. And then some states do require certified crop advisory certification to recommend or sell fertilizers. So all this goes into the importance of having the most efficient use of our fertilizers. Then finally, lawn and landscape quality is another reason why we need good fertilizer efficiency. A proper lawn affects property values dramatically in some communities. We'll see in places in the West like California, Nevada, Utah, Arizona, that the effect of nutrients and how it creates a high quality landscape affects heating and cooling costs. I was involved several years ago in a seminar that talked about the psychological benefits of a proper turf and landscape. And then some communities also require a minimum quality of landscapes in their community, some developments and things. So all this comes into why we need to get the most out of our fertilizer that we apply to the landscape. So what are the things that impact the fertilizer efficiency of our products? And I've put out 6 different things: fertilizer quantity, the source of the fertilizer, when we put it out, where it's applied, and some of the cultural practices that are used in managing this turf grass, and then finally the turf health itself and how it impacts fertilizer efficiency. Now, the first one I want to talk about is fertilizer quantity. There's several research reports out there that look at both warm season and cool season grasses. And you will find, as many people know, that different grasses have different nutritional needs. For example, here in the South, Bermuda has a much higher nitrogen and fertility need than something like centipede grass, that actually, if you over fertilize centipede, it declines and it starts dying. In the northern and cool season areas, Kentucky bluegrass needs are different from that of ryegrass or fescues. And based on that, I can't put it all into one talk, but each university, each state has a university that does research on nutrition needs for each of the turf grasses grown in that state. And they come out with recommendations. So I recommend that each person in their own state look at what their extension service, what their university has come out with recommended quantities, timing, and things like that. It really is important. It's so easy to just guess and over apply or under apply, and it's going to be detrimental to your budget, to the environment, and everything else. So use what these universities have found and follow their recommendations. And also how a turf grass or yard is used affects nutritional needs. For example, a high school football field is going to use a lot more nutrients to repair itself and keep in good shape than a home lawn that occasionally has someone walking across it, or the pets using it in the evening. So take that into consideration when planning your fertilizer. Now, the source of fertilizer also has a big effect on how fertilizers are used and how efficient they are. And there's different kinds of fertilizers. There's the consideration of soluble versus slow release versus what's called controlled release fertilizers. There's a discussion about do you use granular or liquid fertilizers. And then finally, we'll discuss a little bit about macronutrients versus secondary nutrients versus micronutrients, and how they can be used in different ways to maximize results and improve or optimize fertilizer efficiency. The first one we want to talk about is soluble, which are considered quickly available fertilizers. And those products include things like ammonium nitrate, ammonium sulfate, calcium nitrate, potassium nitrate, urea ammonium nitrate, which is a liquid. You have phosphoric acid, which is a liquid. And then you got mono and diammonium phosphates that are very available, potassium sulfate, potassium chloride, and there's a whole list more. There's quite a few different ones out there. So these are the soluble ones that are highly available very quickly and readily to the plant. And now there are several studies that suggested that these soluble sources are associated with increased nutrient losses through things like leaching and the surface runoff that we talked about earlier. But again, this is dependent on application rates, your irrigation practices, the climate, and particularly turf grass itself. And we'll see with some of the studies I'm going to cite that it really does vary. And so it makes you consider, do you use a mixture of fertilizers that have controlled release and soluble, and then maybe a slow release component to it? Is that the right strategy for optimizing your fertilizer efficiency? On the liquid side, which are more also considered soluble, but are on foliar side, there are things like urea ammonium nitrate liquid, which ranges in analysis anywhere from 28% to 32%, depending where you are in the country. There's phosphoric acid, there's potassium hydroxide, and many others that are foliar absorbed. And so the thought is that nitrogen leaching can be minimized by applying a water soluble or a foliar type product at very low rates and less frequently. But the question is, I have on the bottom there, are light frequent fertilizer applications possible in lawn care? And generally this is used in golf course like golf greens, tees, possibly or high-end sports fields. But is it practical for lawn care? And I think the conclusion most people come to is probably not. Except for those areas that have fertigation, and where you can apply a little bit of nitrogen, a little bit of these fertilizer sources out every time you irrigate at very low at parts per million levels. And we see fertigation more used in places. I've seen it in California, in Las Vegas, Arizona, here in Florida, in the South. And in some areas it's starting to grow. I've seen it in Minnesota, but not very readily. So generally, I think we conclude that these highly soluble products are maybe not exclusively to be used in lawn care. But as an example of these, we have some products we make that are examples of this. Turfplex, the 22-3 is a foliar-oriented product that can go out at less than 1/10 of a pound of nitrogen per thousand, a very low rate, and it can go out every week to 2 weeks. That's a lot of labor, but it's an example. And then we have a no phosphorus version of it for those states that, as I mentioned before, ban phosphorus applications during the season. Again, all foliar oriented and designed for light frequent applications to maximize the fertilizer efficiency uptake. Now there's a variety of slow release and controlled release fertilizers. On the granular side, there's this product called IBDU, which was very popular in the 80s and 90s, and we see it more in Asia now than we do in the United States. You probably have all heard of sulfur-coated urea or polymer-coated ureas, which are more controlled release versus slow release. The IBDU needs hydrolysis or water to release the nitrogen. The urea formaldehyde is a slow release that requires soil microbial activity to give its release over time. And the liquid version of that is the urea triazole liquids that we use in many of our liquid slow release products. And then there are products out there that are urease inhibitors. They prevent the enzymes from converting nitrogen into plant and water soluble sources that delay that release and give longer lasting, and also nitrification inhibitors. And there's always the organic sources, things like feather meal, sewage sludges or biosolids and things like that. And these kind of slow release and controlled release fertilizers allow you to apply higher application rates up to a pound of nitrogen at a time or more, but and allow you longer periods of time between applications. So you may be able to go out once a month, every 6 weeks. And some of these are now designed here in Florida to be out, can release over 8 to 12 weeks. So there's a lot of technologies. And to give you some examples of these kind of products, in the BioPro line, we have this EnviroN, which is 70% of this 28% nitrogen product is a slow release form. It requires microbial activity and is from the triazone urea I mentioned before. And so that gives you long lasting, minimizes leaching and loss, and is very effective at getting the most out of your fertilizer. And then when you put those in things like blends, we have a 14410 that again, 65% of that nitrogen is slow release and allows again the same kind of complete fertilizer for all the needs of the plant, but gives you that long lasting effect. And then finally, for those areas that don't allow phosphorus applications in the regulations, a 12012 that gives you nitrogen and potash in a long lasting effective way. So then there are things like secondary nutrients, and there's just 3 of them that we're mentioning: calcium, magnesium, and sulfur. These are sometimes required thanks to soil tests and regionally, but we don't see a lot of those used. But we offer those in things like a calcium plus, a calcium nitrate that allows you a quick calcium boost. Magnesium plus is another one that has the magnesium, and then we have something like All-K that has 17% sulfur, a very high-end sulfur product. Now, one of the things that people forget about are micronutrients, and people think they can get a deep green color with lots of nitrogen, and that can be too much and cause a lot of loss, both through volatilization and through leaching. And the use of micronutrients to maintain color is an excellent strategy, especially in the summer in areas like Florida where you may have nitrogen blackout periods. And so we have, these are all micronutrients, but the ones that are particularly important for maintaining color through the season, through the heat of the season, is something like Spectrum that has a little bit of nitrogen, iron, manganese, magnesium, and sulfur. All these go together to form the chlorophyll molecule, which gives the green color of the turf grass. So something like this, and it's chelated so it lasts longer and can go out at light applications and last anywhere from a couple of weeks to a month, are very good strategies to reduce your total nitrogen and other fertilizers while still maintaining a good color of your turf. And to add to these, if you don't want something that has the whole shotgun, the Spectrum approach, you can pick some that in some parts of the country, manganese is quite deficient and causes yellowing of turf. And so you can do an iron and manganese product, or just an iron alone to encourage deeper color. So there's lots of products depending on what your needs are in your region. All these allow good color while not using excessive amounts of NPK. Then finally, we have one that's called Nutrisolve that has all the micronutrients in, and that would be more appropriate for high sand areas. Maybe like here in Florida, we're one big sandbar. Now, some of the research shows that maybe a combination of all these soluble, controlled release, and others are a better strategy. And here's in cool season, this is out of New England, where Gillard and Kopp looked at leaching losses, different sources of nitrogen applied to turf. And they found that ammonium nitrate, as would be expected, had almost 17% of the whole total amount of nitrogen lost through leaching, whereas a polymer coated urea only had 1.7% loss, and the organic fertilizer had 0.6. So this led these researchers to suggest that in New England, you need a lot higher level of slow release nitrogen, something like in a liquid form would be the EnviroN, something that requires microbial activity to release it. So, and also this other study at the bottom, Frank, et cetera, they indicated that applying like a pound of nitrogen per thousand in the water-soluble form on Kentucky bluegrass enhanced leaching losses substantially. And that doesn't do you any good when you're losing a lot of fertilizer to leaching. So that's declining on your fertilizer efficiency. In the southern areas on warm season grasses, John Cesar at the University of Florida found some of the opposite stuff. That's on St. Augustine grass. They're very efficient at capturing and using soluble fertilizers. And when he did leaching studies, he found that it was less than 1 part per million loss in leaching when using soluble fertilizers. As a matter of fact, he was finding the leachate was less than what they were finding in typical rainfall coming down on Florida. So again, the use of the kind of fertilizer and techniques will depend on the kind of grass you're growing. So again, stepping back to what your universities are researching and what they're suggesting, that is important to follow those suggestions. Now, timing of lawn fertilizer applications are very important, again, for increasing fertilizer use efficiency. We have studies that have shown that turfgrass nutrient uptake is optimized during periods of very high active root development. The more the roots, the more nutrients are taken up. That makes common sense, but sometimes we forget that. And then other studies have shown that if you fertilizer during periods of reduced turfgrass growth, like this early spring or the late fall, you'll see losses, particularly to surface loss. And this was found particularly with phosphorus, losing it to on frozen soils and things. It was lost mostly to surface loss. So if you look at how turfgrass responds, here's cool season turf grasses. You'll see that in the late winter and early spring, you see top growth and root growth increase dramatically through the spring into the early summer. During the summer and early fall, the root growth declines, as does top growth, and then it rebounds again in the fall and the winter. So these give you hints as to when you need to apply your fertilizers. You want to apply them again when your nutrients can be taken up, particularly when you have aggressive and good root growth. In the cool warm season parts of the South, it's a bit of opposite of the cool season. In the winter and the spring and the late fall, you have very low root growth and top growth, but you have strong root growth and top growth throughout late spring, throughout the summer and into early fall. So again, that gives you an idea when you need to apply the fertilizers in those areas. And these timings also important as to when how often you apply it, but also how you follow it up with things like irrigation or rainfall. There's enough data out there that suggests that a light irrigation or rainfall gets a lot more use out of your fertilizer than leaving it on the top. And that's because a lot of products like urea will volatilize. It loses nitrogen into the air as ammonia if you leave it on the surface too long. So there's a lot of data out there that suggests putting a particularly granular fertilizer out and watering it in lightly gets a lot more efficient use out of it. This is also a reason why you may want to use liquids, because liquids aren't being left on the surface. They're applied, and through their water that's carrying them are carried into the root zone. So you get maximized root uptake and use. So again, this is important to maximizing your fertilizer efficiency, whether a granular is really appropriate or maybe a liquid program is better for you. Now, the placement in the soil also is affected by granular versus liquid. There are studies that have suggested that broadcasting granular fertilizers, particularly if you don't water them in, will limit deep root development. And when you don't have those deep roots, as we saw, they aren't there to use the nutrients, and you can lose more of that nutrient to leaching and things like that. And then it depends also on the kind of turfgrass. This one taught and investigated the use of liquid fertilizers versus granular on growing bentgrass. And they found that the uptake efficiency of liquid fertilizer, especially a foliar on bentgrass, you had 100% foliar absorption and uptake compared with 100% granular. So you had much higher uptake using liquids on bentgrass than you did with using granulars. But that does change with other kinds of grasses. We found with runoff that there wasn't a whole lot of difference between liquid and granulars in another study, but they found that there was greater leaching with granulars into the deep root zone, so that the liquids seem to be more efficient at being taken up by the roots as they move through the soil profile. Now, this is a study that Steinke and Steyer did that looked at bentgrass, Kentucky bluegrass, and bluegrass, a subpoena version of it. And these were on golf course tees, but again, it gives you an important response at how each grass responds to the kind of fertilizer you use. The Kentucky bluegrass had a better response to granular urea than, say, bentgrass that did better with a liquid. And then the Poa supina, the supina bluegrass, actually did better with granular in the spring, but did best with liquids in the summer and the fall. So knowing these things help you in planning your fertilizer to get the most efficiency out of it. What's your species, and what are you growing them for in the time of year? Now, cultural practices also have a great impact on how fertilizers are used and how efficiently they are used. One of the first things I always recommend is a soil test. With soil tests, this allows you to understand what your texture is, whether it's sandy, loamy, heavy clays, and the texture affects how well that soil holds nutrients and maybe what kind of fertilizer you should be using. It also actually helps you determine what your actual fertilizer needs are. If you're going out without a soil test, you're just guessing. And you may be applying too much, you may not be applying enough. Also, what's important is that you know what the soil pH is, because pH is very important in how available nutrients are in the soil for the plant to use. The soil test also allows you to identify if you've got excess salts or bicarbonates and whether you need to treat for those. And then finally, it tells you how much organic matter you have in the soil and how that may affect nutrient retention and use throughout the season. As an example, on the soil pH, you can see from this table, and you can see all sorts of versions of these on the internet, that you'll see why most professors and universities recommend you keep a pH between 6.2, 6.3, and 7, because you'll see that the green in those areas for all your nutrients are maximized there. So if you're way off in in New England with a pH of 5, you're not getting the most out of your fertilizers. The plant just can't take them up. It's not available. Or in the West, where your pH gets well above 8. And this gives you a clue as to what you need to do to maximize your fertilizer efficiency. So that's going to be through things like adding lime to raise pH, and then most people use something like sulfur products to help reduce pH. When you have things like salts, calcium is the most important thing to use. A lot of people use gypsum, but we have a product called NAX, which is a calcium liquid flush that helps flush those salts out very rapidly from the soil and allows them to be leached out and allow the turf to do much better and perform better. If you've got high bicarbonates like you see in the Midwest and Ontario, you need something that's an acid forming fertilizer like this Neutralize, which the sulfur is converted to sulfuric acid when it goes through the biological processes and breaks down those bicarbonates and allows those plants to perform much better. So this, when you use this, you're getting the bicarbonates, and with NaX, the salts out of the way so that your plants can utilize your fertilizers much more efficiently. There's also a discussion about clippings, and a lot of people don't talk about, but research has shown that clippings can store up to 25 to as much as 60% of the nitrogen applied through fertilizer. And if you're taking those clippings off and removing them or throwing them away, you're throwing away a lot of your fertilizer. So most researchers are now indicating that in lawn care, it's better to leave the clippings behind. You don't need to apply so much fertilizer, and that you're recycling those and it also happens to add a lot of organic matter to your soil, which is always benefiting nutritional cycling in the soil. So clipping management it affects the nitrogen dynamics in the soil turfgrass systems, and it can, but it does not. With research has shown that it doesn't affect phosphorus as much as nitrogen. Moisture manager is another big area. If you don't have proper moisture in the soil, your nutrients can't move and be taken up by the roots. Many studies have demonstrated that proper fertilization and irrigation, properly irrigated and fertilized turf, has a significantly less leaching of nutrients and soil runoff. So Penn State and other universities caution not to overwater turf. And we see that so many times. I see in turf management that either people overwater or underwater. And so often they overwater, and then they're pushing these nutrients out of the root zone, and you're losing them to leaching or sometimes through surface loss. So it's very important to have the proper soil moisture, irrigate correctly, and that will maximize your nutritional uptake. And there's lots of products that can help with managing soil moisture. You know, most people are familiar with wetting agents or surfactants that allow moisture to move into the soil, disperse through the soil, and even move through the soil, and that they're used heavily throughout the turf industry. You've got super absorbent polymers, which are more difficult to use, and because you just can't get them. They're crystals that absorb moisture and expand and hold the moisture like a sponge, but it's very difficult to get them into established turf areas. And then there's something like hydrotane, which is a hygroscopic humectant that works totally differently in that it absorbs moisture out of the air. It condenses it like a cold drink coming out of the fridge condenses water on the sides and holds that. So that's a hygroscopic materials track moisture out of the air, condense it, and the humectants hold it for the plant to use. And we see this in this demonstration where when they're in the root zone, they're like tiny water magnets that condense and create droplets that the plant can use, and you get much more water out of your irrigation dollar. And then we see this happening in things like, this is out of Australia, where you can see that it's applied, the hydrotane was applied during the wet season. This is 6 weeks into a drought, and you can see how much better that turf is performing. And you have to come to the conclusion that that turf is taking up the nutrients a lot more effectively than the yellow turf around it that just isn't performing. It's just not able to take up the nutrients. And once you do get rain, those nutrients are going to be susceptible to loss through leaching. We also see that in potted plants. This is a study out of Clemson where you can see by using hydrotane, you've got a much better developed root system on the right there. The plant is bigger and obviously is taking more nutrients out of that soil. And that's been proven through a study done for us by Western Illinois University that looked at plant uptake of nutrients out of the soil. And they analyzed 11 nutrients, and 9 out of those 11 nutrients saw significantly greater increase in uptake and use by the plant. The only 2 that weren't significant were iron and zinc, but while they were increased, they were not significantly increased over the controls. And that's important in showing that when you manage moisture properly in the soil, you're going to get greater fertilizer use efficiency. You're going to get better color. You're going to get better quality and density of your turf. And you're going to get all the benefits that come from that, like disease resistance and tolerating other biotic and abiotic stresses. Another study in the University of Illinois also demonstrated that, where we looked at the three forms of hydrotain, a liquid on the left. The second one from the left is the a gypsum carrier called QD, and then the organic carrier is the next one. The far right is the control. And you can see after 12 days only, you can see those plants are larger, they're got larger leaves, they have more flowers. They're obviously taking up more nutrients, so that moisture management in the soil is creating a better fertilizer use efficiency. And when you take it to extreme drought conditions, you can see how all the plants have deteriorated from the severe wilt, the drought. But after a day after watering, the ones with the hydrotain respond very quickly. And again, they're back to using what nutrients they have available and continue their growth with little problems. We see the same thing in peppers, the same pattern: liquid, the QD, the organic compost one, the control. And you see that the leaves are larger, the plants are taller, they're just performing better. They're just getting more fertilizer out of that fertilizer dollar you're putting in. And when you take them to a severe wilt, again, they respond very quickly, a couple of days, a day or two after irrigating. And we see that when you get into seeding, with hydrotain, you get faster seed germination. And so those plants can start utilizing the fertilizer, the nutrients in that soil much quicker, rather than them being leached out through excessive irrigation. We see that also in the greenhouse when we see quicker germination. And the lettuce on the far right side was already germinated. You can see how much greener that is. Those plants are larger. They're obviously getting more nutrients out of the use of the hydrotain there, and they're just developing much quicker. We see that also in the landscape with something like begonias. The ones on the left had hydrotain included as a granular at planting. The right was not. There's no irrigation on these, and you see those plants on the left are performing well with just whatever Mother Nature gives in the form of rainfall. Again, in optimizing the nutrient uptake of the nutrients in that soil. Very important is how it is very important that we manage the soil moisture to optimize nutrient uptake. So the applications of hydrotain are things like 9 ounces per 1,000 on turf, or you can split that up at every 3 months, put out the 9 ounces and 3 ounces every month, or you can put out 2 ounces per gallon and drench your landscape plants. There's more details on the hydrotain website. There's also the granular that on lawns you go out at 3 bags to an acre, or 2.7 pounds per 1,000. One of those bags covers 14,800 square feet, have the same effect. So moving from moisture management to root management, we find that as we saw earlier with the seasonal root development, that turfgrass nutrient uptakes is greater when you have more active root development, or when you have greater roots. And then Bowman in 2002 compared 6 warm season turfgrass species and identified species selection as an important factor in contributing to potential nitrate loss. The root length and density contributed to how much you lost. So the greater the root density in like Meyer's zoysia grass, the less loss of nitrogen you found in that. And St. Augustine, as we mentioned earlier, is much more efficient, but we see that across all turfgrass types. The greater the root mass, the greater uptake of nutrients and the less loss to leaching. So when we get into managing roots, we have a product called Cytogrow, which is a product from seaweed that has cytokines and auxins, hormones that are used and are developed by the plant naturally to enhance root development, density, length, things like that. So we see the use of Cytogrow very often in promoting greater root, even in the summer months on cool season grasses where they're declining. That can help maintain those roots, so you're getting the most out of your fertilizer application. So you can use that new plantings, new seedings, as well as in maintenance. You know, we see that in planting sod, those roots are out of there. This is some sod in Wisconsin that 6 days after, those roots are already out of that sod and into the soil, maximizing the amount of nutrients they can utilize and uptake. And when we take it to lawn care, we see this in Tennessee, where on the right where Cytogro is used, you got a greener turf, you got a better density of turf. It's just all around better turf. That's showing you that that turf is taking up a lot more nutrients than the turf on the left. So the Cytogro is really helping that root mass develop fully so it can optimize the use of nutrients that are put out there. And we see that also in Bermuda grass and sod production, where it's used in promoting the development of that sod. The runners are running a lot quicker, they're filling in quicker, and again, utilizing any of the nutrients that are available in that soil much more efficiently. And then we seed with something like this is a fescue. Again, that seed is filling in quicker, and you're getting a lot more use of the nutrients in that soil. You're just, when you got more plants there, you got better density, you're getting a lot more efficient use of your nutrients. So soil biology is another thing that really affects fertilizer use efficiency. You know, there are many soil functions that rely on soil biology. There's nutrient cycling, there's a carbon cycle, there's a nitrogen cycle, there's all sorts of cycles out there that nutrients go through, and biology of the soil really affects that. It affects nutrient retention. When you've got more microbes consuming those nutrients and holding them, they're not going to leach out. They also put them in the carbon sink in the soil so that they can be released at a later time. It affects soil structure, which affects aeration and drainage, so that, you know, when you have proper moisture in the soil and you got proper air levels, you get them optimizing your nutrient uptake. Soil biology can also help to suppress diseases, and it also degrades other pollutants that may damage the turf. So all coming together to form the best possible turf that uses your nutrients at the maximum. So what environmental things influence soil biology? There's aeration, amount of air in the soil. You don't want aerobic conditions, rather anaerobic or without air. Soil moisture, as we talked about, it really impacts soil biology. The temperature, the acidity, as we talked before, you want to have a near neutral, a 6 to 7 type acidity for maximum soil biology. The amount of organic matter possible, that's a carbon content, and then how deep that soil biology goes. So there are a lot of product classes that are used to enhance soil biology. We have beneficial microbes that we see on the market. We see humic substances like humates. We see metabolites, things like sugars and other things. We have plant growth regulators. We see seaweed products, and then enzymes. And to give you some examples of these, we offer one that's called BioMP. That's a molasses-based product that adds a lot of energy. The molasses allows those microbes to grow, to perform better, and we see it in how it helps nutrient cycling and how it breaks down thatch that builds up in the soil and things like that. So something like this, metabolite in the molasses, really helps that nutrient cycling. We have an Enviroplex that's a 22% humic acid product that, again, adds to the carbon source that helps that soil biology perform better. It helps increase soil structure. It's a carbon source. It helps the microbes as a food source to help with nutrient cycling. So all these come together to help improve nutrient cycling and efficiency. And then we have a seaweed product that's a sister product of the Cytogro, again, that will help as a plant biology enhancer, a microbe food. So another cultural practice that we need to consider is making sure a fertilizer gets on the turf, gets in the landscape. We see many state laws now forbidding you to leave fertilizer on pavement. So make sure the fertilizer lands on the turf. You know, it's a waste. Micronutrients, if you leave them on the turf, like iron, will stain. You'll have little orange spots or polka dots. that's not very appealing to your customers. We also have the Turfgrass Health. That's another cultural practice that it really improves nutrient efficiency. You know, if you have a healthy, vigorous growing turf grass, it's the most efficient at extracting and utilizing those nutrients you're putting out through fertilizers. So you need to also select and maintain the proper turf, that's the species, the kinds of plants for the site. You need to manage your biotic pests. You know, you need to control diseases and insects. If you allow them to invade and tear down and decline the turf, you'll have less nutrient uptake and you're going to get less efficient use out of it. And then also manage your abiotic stresses. You know, heat's a little bit difficult to manage, but you can manage moisture, as we talked about with hydrotane. You can manage your pH, you can manage your salt levels, bicarbonates, and things like that. So it all comes together that a healthy turf grass is going to be your most efficient stand for using fertilizers. So as we come to an end, what are the takeaways we have for maximizing fertilizer efficiency? You know, it's important in today's economic climate that we maximize fertilizer use efficiency. There's no way we should be wasting that fertilizer dollar. We need to protect our environment, both our groundwater and our surface waters. So we need to make sure that all that nutrients we put out are taken up by the plant. There are many options we need to take away that are fit different geographies, different management styles. There's liquids, there's granulars, there's all sorts of different soluble versus controlled slow release. All of these can come together in a strategy to maximize your fertilizer efficiency. So as we go in to design a program, we got to remember we use the right nutrient source for our site. We use the right fertilizer rate for our site. We use the right application timing so that the roots take up all those nutrients. The right placement, so we use a liquid to get it into the root zone more efficiently, probably than a granular that has to be watered in. Use the right cultural practices like moisture management and taking care of our insects and diseases. And then we take advantage of those supplements that can help increase fertilizer efficiency. Your water management products, your seaweed products, your microbial aids. Use all those things that help that soil and your plant take up every possible bit of that nutrient you put out. And then finally, maintain healthy plants because they are the most efficient at using nutrients. So I thank you for joining me this afternoon. This is a time for questions if you have any, and if you want to send me questions otherwise, you can email me or call me. I'm happy to take questions. Thank you.
Thank you, Jim. That was great. We'll give a few minutes for people. If you have questions, put those into the chat for us and we'll get those answered for you.
You're welcome.
Getting a couple of thanks for the information, Jim, in the chat.
No, you're welcome. Thank you.
Pictures in comparison. Jim, one of the questions that did come in is, you know, carbon has become such a buzzword in the industry. It's being used in a lot of different places. How important is carbon to, you touched on it a little bit, but how important is carbon to the nutrient uptake process, and are the products that are on the market really effective at improving nutrient uptake, or is it more hype than function?
Yeah, it's interesting to look at that. Carbon is very important to a plant, to people, but the kind of carbon, not all carbon sources are equal. You know, we've for years we've known from farming going back thousands of years that incorporating compost and plant materials improve plant performance, and that's the carbon source. You're getting a carbon source for the microbes in the soil to do their thing. They use it as food and then release nutrients and all that. But some carbon sources are not readily available. They're tied up, and sometimes you're putting out products that you're only putting out 100 pounds per acre, whereas you look at what's called an acre furrow slice, an acre 6 inches deep, that's 2 million pounds of soil. 100 pounds of a not very available carbon is not going to do you a whole lot of good in your soil. So the kind of carbon you're adding in, something that's readily available that the microbes in the soil can readily use, and the carbon is also used by the microbes to help tie up and to sequester nutrients and then release them later for the plant to use. So, and that's important that you have carbon in your soil. Like sandy soils are a real problem because they don't have enough carbon. But it's got to be the right kind of carbon that's available. The microbes can use to sequester, hold those nutrients and slowly release them. Otherwise, those nutrients, if they're very soluble, are leached out and are lost to the groundwater.
So we received a couple follow-ups on that. As I was reading the question, one was actually being asked about that. Do you recommend a carbon source to a low CEC soil?
Yeah, and CEC refers to cation exchange capacity. It's the cations are positively charged ions, and is it the ability of the higher the CEC, the more it holds those nutrients. So that, yes, you want, and the right kind of carbon source can really improve your CEC, especially in sandy soils. And that's where compost comes in. Your humates are very high in CEC, and so they can be very effective in that. So yes, it's important, especially in sandy soils. And on heavier soils, it helps because it loosens up the soil too when you get a lot of compost in there. It allows for more aeration that helps that soil biology.
Another one was, we have severe drought here in Utah. What do you suggest for sports fields?
Well, in Utah, I understand that salts are an issue, so you need to maintain, control your salts through not carbon, but calcium sources, whether it's NaX or gypsum or something like that. And then you need to irrigate properly. Less frequent deep irrigations we find are better for root development, and the deeper the roots, the more they can scavenge and find nutrients in water. But something like a hydrotane we are seeing being used very effectively in Utah for utilizing what little water you can put out. It's condensing it and holding it for the plant to use rather than losing it through evaporation into the atmosphere. So I've been to Utah several times and worked with golf courses and lawn care guys, and they've had very good effect on using something like a hydrotane. But keep your organic matter up, controlling your salts, and using something like a hydrotane to maximize what moisture you can have in the soil makes all the difference in the world in maintaining sports fields.
We received a follow-up to the question about low cation exchange, which was, is that why you want to use something like molasses for immediate consumption and humate for a longer term food source?
Yes, molasses is very available, and it's going to be used very rapidly by the microbes, and they'll expand. And they'll have that effect. And humates do last a lot longer. They're a more stable source. And yes, a combination of them together is very effective. And we're seeing that in some of our arboriculture stuff that we're doing, both the BioMP and the Enviroplex, and seeing very good results in places like Texas. So yes, molasses, the speed in which they react, each have their own advantages. So yes, I would add a molasses product like BioMP for a rapid response and really boosting those microbial activities in the soil, where humates will last a lot longer and hold those nutrients and things like that for much longer.
Excellent. Thank you, Jim. That so far that wraps up the questions that are in our chat at the moment. So again, we'll give it a few more minutes if anybody else has any other follow-up questions.
Okay. Well, again, I thank everyone. So thank you so much. Again, feel free to contact me if something hits you later on. Here's my email address and my phone number. I'm happy to talk to anybody.
Thank you, Jim. Thank you all for joining us today.
Goodbye.